All right, folks, it's Bass Action, back in action here. In this video, we are going to go through what are called conditional statements, and then we're also going to look at counterexamples and ways to rearrange conditional statements. So the counterexamples are going to help us understand and figure out whether a statement is true or false. So we did our truth tables last time, and we just analyzed it possibilities, and now we're going to look at how can we actually determine and prove that something is false. So let's start here at the top. One thing you're going to notice in this video is that I've already filled in some of the blanks. In fact, I filled in most of the blanks because there's a lot of writing here. So what might help you in following along is if you also pre-fill out your foldable and then kind of follow along and make some notes as we go along. So I thought it might be a little easier for you to follow if I wasn't trying to write and talk at the same time. So I'm going to start here at the top, a conditional statement. A conditional statement is simply a statement that's been written in if-then form, okay? It just means that the statement says if something, then something else. It's important to understand that a conditional statement is not necessarily true. We can say whatever we want to say, but it doesn't have to be true. Now, the next part is going to sound like your science classes. The if part is what we would call the hypothesis. The then part is what we would call the conclusion. Very similar to the language from your science classes. This next part is really important, all right? For a conditional statement to be true, okay, for it to be true, it must be true for all possible cases that exist. Now, obviously, it's going to be difficult to test all possible cases, so the best thing that we can do is start to understand how to show that something is false. In order to prove, and we mean the word prove without writing out a long proof, in order to prove that some statement is false, we only need one counterexample. And the analogy that you'll hear me talk about in class is how many holes does it take to sink a boat? It only takes one hole to sink a boat. And as long as the boat is leaking, the boat is going to sink. So it only takes that one hole. Thus, we only need one counterexample. I need to find one place that something fails and the whole thing fails. It doesn't matter all the places that it might be true. All it matters is that true means always true. So if we find one place it's false, it is a false statement. So let's take a look here. We want to prove that these statements are false by finding a counterexample, all right? A counterexample is any example that will satisfy the hypothesis but not the conclusion. So the two statements that I'm giving here in A and B, I'm telling you are false. Now, we want to prove it. So what you can see I've done in different colors is I underlined the hypothesis in one color and the conclusion in the other. So if I want a counterexample, I need to show, give an example of a number that's odd, that's going to satisfy the hypothesis, but I also want that number to not be divisible by 3. So I need to think of an odd number that is not divisible by 3. You can think of lots of numbers that are odd but not divisible by 3. There's many, many. I could think of the number 1, that's odd, not divisible by 3, 5, 7. There are many, 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 many examples, but as long as you can give me one of those, I know that this statement is considered false because true means always true. Then we've got another scenario here. I've underlined the hypothesis in blue, the conclusion in red, so the counterexample would satisfy the blue and fail the red. So we need to show or think of an example where I could have a full tank of gas, but my car won't start, okay? Now again, there are many scenarios where that could happen. The one that always comes to my personal mind would be a dead battery, okay? This happens to me a lot. Leave the lights on in my car and the battery's dead, so my car won't start. It doesn't matter how much gas I have in the tank. That is a counterexample on why this statement is a false statement. Okay, so that's counterexamples. You guys are going to get comfortable with those. So what I want you to really remember on those counterexamples is that it has to be something that satisfies the hypothesis and fails the conclusion. And doing this little, writing this out of what you're trying to show is very, very helpful. Next, we are going to write some statements in an if-then form. So I'm going to give you a sentence, and you're going to turn it into the conditional, the if-then. Now, in general, we can start at the beginning of the sentence and go and find the verb, and that'll help us find the hypothesis. But the first thing that we want to do is we always want to look at a statement and see if somewhere in the statement they've already given us the word if. So if somewhere in the sentence we find this word if, that is the beginning of the hypothesis. So I find that word if, and everything that follows becomes my hypothesis, and then the beginning of the sentence will be the conclusion. The key is that this problem already had the word if in it. So when I write this in my conditional form, I need to make it sound like a good English sentence. So I would say if, I don't want to say if they, because I don't know what they is talking about. So I'm going to say if 2 points, because reading the whole sentence, I know the they is referring to 2 points. So if 2 points lie on the same line, then now I can use my conclusion. Now I can use the word they, then they are collinear. The next part, this one, if I scan the sentence, I don't find the word if anywhere in here. So to find the hypothesis, I started at the beginning and I just kept reading until I came to the verb. And as soon as I come to the verb or that action, I know we've now flipped to the conclusion. So putting this in if-then form, I say if a number is divisible by 9, that's the blue part, then it is also divisible by 3. Done. You don't have to test whether these are true or false unless I ask you to test whether they're true or false. So oftentimes the true statements will clearly be true by a definition or a theorem, and the false statements will obviously be false, and then you will find a counterexample as we just discussed. Now, the next thing that we can do is we can rearrange conditional statements. So down here on the bottom, I have another place where we're going to practice writing the conditional, and then we're going to take the conditional and rearrange it many ways. So the first part here, this is the sentence I'm working with. It's the same one for both parts here. I underlined the hypothesis in blue. I got to the verb, then I found the conclusion. So on our conditional, I took that hypothesis and said, if an angle is 30. I don't want to say if 30 degrees angle because it just doesn't sound like good English. So I say if an angle is 30 degrees, then switch, then it is acute. Notice the blue came first and the red came second. On this next one, we're going to call this a contrapositive, and what I want you to notice is what I did. Notice that I started with the red and I inserted this word not here, okay? So instead of starting and saying, if an angle is acute, I said, if an angle is not acute. And then, instead of saying, if an angle is, then an angle is 30, I said, then it is not 30, okay? Those nots are important to us. What we want to be able to see here is these two different ways that I could write the same sentence. The first one, the conditional, if I call the hypothesis P and I call the conclusion Q, the first one, the conditional, can be represented symbolically by P, the arrow is red, this is red, then Q. So the conditional is red, P, then Q. The contrapositive, however, started with a Q, and I had the not in there, which meant I negated it, and I ended with what had previously been identified as the hypothesis, and it was negated. So symbolically, the contrapositive is the negation of Q, then the negation of P, looking at the original conditional. If we want to analyze the truthfulness of this, we would just ask ourselves, hey, if an angle is 30 degrees, do I know it's acute? And as I said before, some statements will be obviously true or obviously false, and this one is obviously true. I know that 30-degree angles, by definition, are acute. The next one, if an angle is not acute. So now I'm thinking of some angle, but I know for sure it's not acute. Can I ensure that the angle I'm thinking of is definitely not 30 degrees? And that is true. That was a little harder to analyze with those negations in there. Now the next one, so we're just going to set those aside. Now we're going to look at another way to rearrange it. On our next one, we have if an angle is acute. Now I can see I'm starting with that conclusion, but I didn't add a negation. So this time, symbolically, I've started with just the Q, and then I've gone to the P. So on this one, all I did was take these and flip them around, okay? On the contrapositive, I flipped them and negated, but on the converse, I just flipped them around. For the inverse, I'm going to still start with the blue and end with the red, so my order stays the same. So I'm going to start with the blue, and I'm going to end with the red. But if I look at these more closely, what I can see is I'm saying now, not if an angle is acute, but I'm saying if an angle is not 30 degrees, I'm saying if it is not 30, then I'm going to say that then the angle is not acute. So this one, I'm doing the negations. So before I go any farther on this, what I want you to know is you need to know that the conditional is this symbolically, P then Q. The contrapositive is this symbolically, negation of Q, then negation of P. The converse is Q, then P. The inverse negates them but keeps their order the same. That is important for you to know. Now, let's take a look at the truthfulness. If an angle is acute, do I know it's 30 degrees? And that is false. If we're thinking counterexample, what I want to know is I want to think of an angle that's acute but is not 30 degrees. Satisfy this, fail this. And there are many angles. 29 degrees is acute but is not 30. So this question is definitely false. Then analyze this truthfulness. If an angle is not 30, then it is not acute. This one's going to be harder. I need to think of an angle that's not 30 degrees. Let's think 29. Is that angle not acute? Or is that angle acute? Okay, so I'm thinking of an angle that's not 30, but then I need it to also not be, or I need it to be acute. And this one is also going to be false. Again, those negations are going to be harder to analyze. Now, if these negations were hard to analyze, let's take a look at this equivalent statement. I'm going to come back to this one in just a second. Equivalent statements are statements that are either both true or both false, which would mean if we come back up here that the conditional was true and the contrapositive is true, and since they're both true, the conditional and the contrapositive are equivalent. What that tells us is that if we're given something that's written like this, and we think, hey, I don't like it written that way, I can write it as this form, okay, thus taking the knots out. I can write it in this form and analyze it better. The same thing here. This is false and this is false, which means the inverse and the converse are equivalent. The last thing that I want to do is I'm going to circle back here to this question, which if the hypothesis is P and the conclusion is Q, symbolically, how can we represent a counterexample? A counterexample was something that satisfied the hypothesis and it failed the conclusion. So it's a P and not Q. Okay? So this is a lot to take in. When you come to class, we're going to do a whole bunch more practice with this, just practice writing these words. But between now and class, just start to get comfortable and committing to memory the symbolic notation for the different statements and how we find a counterexample.